these are the chapter 3 review exercises. I'm going to do some problems. Obviously, these ones I'm doing, high probability of seeing them on the test. Numbers 1 through 4 are operations on complex numbers where we're adding or subtracting think combined like terms. Number 2, simply treat the imaginary unit I like it's any arbitrary variable x. When we're subtracting complex numbers, keep the first parentheses the same. Changing the addition to subtraction and change the signs or operators in the second parentheses. Now combining like terms. The real part, 6 and minus 10, combines for a minus 4. The imaginary part, minus 5 and minus 3, combine for a minus 8i. Number 3, you would simply distribute, remembering that I squared is a negative 1. Make that substitution. On number 4 here, let's look at the complex conjugate. So if we have the fraction 2 minus I over 2 plus I, one of our conventions in math says that we won't leave a square root in the denominator, and so this I is the square root of negative 1. So we will eliminate it from the denominator by multiplying by its conjugate, and the conjugate of 2 plus I is 2 minus I. Multiplying by 2 minus I in the numerator and the denominator. In the bottom, recall how we multiply a complex number times its conjugate. You just square the first number, square the coefficient of the I portion, in this case 1, and 1 squared is 1. 4 plus 1 is 5. It ends up being a plus in the middle because I times I is I squared, which is negative 1, and a negative is a positive. Multiplying 2 minus I times 2 minus I. I'll come up here and do that. 2 minus I, 2 minus I. Distributing, 2 times 2 is 4. 2 times minus I will be a minus 2i. We'll have another factor that is minus 2i, or another term that's minus 2i. And lastly, minus I and minus I is a plus I squared. Well, I squared is negative 1. Combining these two gives a minus 4i. And then we have a 4. 4 minus 1. 4 plus a negative 1 would be 3. Minus 4i. That'll be our numerator. Perfectly fine way to write the answer. We could also write it as 3/5 minus 4i over 5. 4/5 I. Number 5 and number 6 says solve equations over the complex number system. I'm going to look at number 6 here. I'm going to go right to the quadratic formula. We have x squared plus 2x plus 10 is equal to 0. First we set the equation equals 0, done. Then we identify a, b, and c. A is 1, b is 2, c is 10. Now find the discriminant, b squared minus 4ac. That's going to be 2 squared minus 4 times 1 and 10. So that's 4, and that's 40. 4 minus 40 is a negative 36. When the discriminant's negative, we know there's going to be no real solutions. If we graphed it, it would never touch the x-axis. We know we're going to have these imaginary solutions. 2 of them. They always come in pairs. 2 complex solutions. Rest of quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b will be negative 2 plus or minus. We've already found this part. It's negative 36. 2a will be 2 times 1, which is 2. If you remember nothing else about I, know that it is an object that helps us deal with the square root of a negative. Well, square root of 36 is 6, so we have negative 2 plus or minus 6i over 2. 2 goes to both of those numbers, becoming negative 1 plus or minus 3i. All right. Looking at 13 through 16, it says, determine if the function is a polynomial. I won't ask you to identify a polynomial, but it's a polynomial when it's something like this. We have terms. Poly means many. It doesn't have to be many terms, but it can be. And the terms are to whole number powers, not negative powers, not something to an, like this one here is not a polynomial, all right? But I want to ask you to identify that. 16 through 18 here, that says determine the end behavior. Remember the situation with our end behavior. Your two questions to ask yourself. What is the parity? That is it odd or even? And what is the sign of A? The leading coefficient is plus or minus. If it's odd and a positive, think y equals x. If it's odd and negative, because y equals x is, that's an odd power, first power. If it's even and positive, think y equals x squared. If it's even and negative, think y equals negative x squared. That'll help you answer all the questions. So for number 17 here, it's an even A, 4. It's an odd power. So it's going to behave like this. You would say as x approaches positive infinity, as we move to the right, this graph is moving up. Y, or f of x, also tends to positive infinity. As we move left, as x approaches negative infinity, f of x approaches negative infinity. I don't think I'm recording. Uh, 19 through 21, we're finding all the zeros of the polynomial noting multiplicity. So multiplicity is just a repeated root. So in the case of number 19, clearly where we have x plus 3, the 0 is going to be x equals minus 3. And we say it's a multiplicity of 2 because it's squared. There's 2 copies of it. I could write this as x plus 3, x plus 3. This is a multiplicity of 2. This one here would end up being a 1/2 if we set it equal to 0. Multiplicity of 1 is to the first power. This is x plus 1. That would yield a 0 of minus 1, and it would have a multiplicity of 3. So all the multiplicity is the number of times that factor can be written in the equation. Let's do number 20 here. Number 20 states f of x is equal to x to the 5th plus 4x to the 4th plus 4x third. I'm going to try to factor this. When factoring, look for the GCF first. Since they all have an x, I can factor out some x. How much? The least power. In this case, x cubed is a factor of everybody. Dividing out x cubed leaves x squared plus 4x plus 4. X cubed times x squared is x to the 5th. X cubed times x to the 1st is x to the 4th. X cubed times 4 is 4x cubed. Note that since we factored out an x cubed, they all went down by 3. 5 exponent becomes 2, 4 becomes 1, and 3 is none. All right. I can further factor this one. X times x yields x squared. When the last operator is a plus, we'll have 2 of that first one. And this is going to turn out to be 2. 2 times 2 is 4, but also 2x, and 2x is a 4x. So since it's x plus 2 twice, I can write that as x plus 2 squared. So we have x cubed and x plus 2 squared. If we set this one equal to 0, it would yield x equal negative 2. And since we have 2 factors of it, we say this has a multiplicity of 2. Okay, this one, if we set equal to 0, clearly we would get x is 0. And since it's cubed, this has a multiplicity of 3. Number 25, it says divide using long division. We can use synthetic division. I'm going to show synthetic division. I feel like y'all are pretty good at it, but you will have to do it on the test. So let's do a couple for practice here. Actually, they 27 through 30 say use synthetic division. We'll do that. I'm going to do number 30 here. It's a good example of a special case. So we have we strip off the coefficients. My coefficients here. My coefficients there are 3, the cubic one. 3, the fourth powered one. 3, the cubic one. Note there we have a cubed but no squared. And when that's the case, you need a 0 placeholder. You can think of this as being 0x squared. And then we have a 2x and a 2 constant. We're dividing by x plus 1. You can think of it as using the associated 0, which would be minus 1. Technically, this opposite affects the idea in division of subtracting as opposed to adding a negative, which is what we're doing here. Bring down the first number. Then we have this looping process. Negative 1 times 3 is negative 3. Adding is 0. Negative 1 times 0 is 0. Adding is 0. Negative 1 times 0 is 0. Adding is 2. Negative 1 times 2 is negative 2. Summing here is 0. Since we were dividing into a fourth power, this becomes a third power. So this is 3x third plus 0x squared plus 0x plus 2. And there's no remainder. Clearly we don't have to write those. So we would have is 3x cubed plus 2. Further, we could write that numerator as a product of what we divided by times this. So f of x, if f of x was 3x to the fourth plus 3x cubed plus 2x plus 2, we could write it as what we divided by, which was x plus 1, times this thing that we received, the quotient, 3x cubed plus 2. Note, x times 3x cubed would be 3x to the fourth. X times 2 would be 2x. 1 times 3x cubed would be 3x cubed, and 1 times 2 would be 2. All right, this will be a first video. I will post another one later this evening.